Hello, we are going to be starting electrochemistry today, which is chapter 20 in our textbooks. First thing that we're going to do in this video is to go over some of the basic redox and electrochemistry ideas that we addressed in Regents chemistry. All right, most of this should just be review from Regents chemistry. So depending on how well you remember that, this may be a little bit easier, a little bit harder. So redox consists of a reduction and oxidation. These are supposed to be arrows there. So all redox reactions consist of a reduction and oxidation reaction occurring simultaneously. In our redox reactions, we have a transfer of electrons. So one substance is losing electrons, the other substance is gaining electrons. Now, our two half reactions are oxidation and reduction. So oxidation, the oxidation number will be increasing, and that occurs when we lose electrons. So in this example, sodium would start with an oxidation number of 0 and go to +1. So 0 to +1, that's an increase. Therefore, it has to be an oxidation. And that happens by losing electrons. The sodium atom would have 11 electrons. The ion would have 10 electrons, so it's lost an electron. All right, reduction. In reduction, the oxidation number is decreasing. So this would be going 0 to -1. So our oxidation number is decreasing. So hence reduction. And that occurs when we gain electrons. So Cl would have to gain electrons in order to become the Cl ion. Now, hopefully you remember, Leo the lion says grr. That's just one of those mnemonic devices that helps us remember what's happening. So Leo stands for losing electrons is oxidation, and then grr, gaining electrons, is reduction. So this just sometimes helps you with those multiple choice questions. All right, two other pieces of vocabulary: oxidizing agent and reducing agent. So when you see the word agent, you have to think opposite. So oxidizing agent is the substance that gets reduced. Reducing agent is the substance that got oxidized. So in an oxidation, there is a loss of electrons. Those electrons then go on to facilitate the reduction reaction, because those electrons then are used for the reduction reaction. So that's where the name comes from. But agent, think opposite. So oxidizing agent, thing that gets reduced. Reducing agent is the thing that gets oxidized. So good oxidizing agents would be things that get reduced easily. So things that gain electrons easily. So that's going to be our group 17 halogens, would be substances that get oxidized easily. So substances that lose electrons easily. So that would be metals, more specifically group 1 and group 2 metals. All right, so this is just a quick example. So first thing we have to do is assign the oxidation states, and then we need to write out our half reactions and then identify what's being oxidized, what's being reduced. So first off, magnesium would have an oxidation number of 0 because it's by itself. Same thing with the O2. Then in the compound, magnesium oxide, here we're going to have things other than 0. So magnesium would be +2 and oxygen would be -2. So then when we go to write out our half reactions, you will always only have two half reactions. Two halves make a whole. So our two half reactions would show oxidation and reduction. All right, this one here, we're going from 0 to +2. So that one is an oxidation. Now we would need 4 electrons over here. So the magnesium atom is losing 4 electrons because each magnesium would be losing 2 electrons. So we have 2 times plus 2, that gives us plus 4. Then the 4 electrons gives us negative 4. So now both sides of the arrow have a charge of 0. My other half reaction would be for oxygen. And I go to 2 oxygen ions, 0 to minus 2. That's a decrease, so therefore that's a reduction. In order to become a negative ion, we must gain electrons. Each oxygen needs to gain 2 electrons, so 4 electrons total. This way now the charge is going to be minus 4 on both sides of the arrow, so it's going to balance out. So we did oxidation states, we wrote our half reactions, identify what's being oxidized. The magnesium is what's being oxidized, and what's being reduced would be the O2. All right, when we balance out our reactions, like we just saw there, we have to have the same number of electrons in the oxidation and in the reduction, so therefore the electrons are just transferred. So whatever's being oxidized loses, say, 4 electrons, and then whatever being reduced gains 4 electrons. We also need to balance the the charge within the half reaction to make sure that the charge is the same on both sides of the arrow. So if you are given an unbalanced equation, you can balance it through normal methods, or you can use redox reactions or half reactions to help you balance it. This example down here, if we just put ones in front of our 4 substances, it would be balanced in respect to mass, but not in respect to charge. So we have to balance out the charge too. So if we want to do this by using the half reactions, we have to start by writing out the half reaction. So iron would start with 0, go to plus 3. That is an oxidation. And we would need 3 electrons over here on the right-hand side. Then copper plus 2 is going to copper 0. That would be a reduction. And I would need 2 electrons on the reactant side. Now the electrons need to be equal and opposite. So what you do is you just take the iron reaction, multiply that by 2. So we're going to put 2's in front of the irons, and we take the copper reaction, multiply that by 3. Now the reason why we multiplied by 2 and 3 is so that we would get an equal number of electrons. So that way I would now have 6 electrons that are being transferred. Then this is just a simple one, so everything's already balanced out, but sometimes you might have a few additional atoms that you might have to balance out. But we have 2 irons on each side, 3 coppers on each side. Total charge is plus 6 on both sides. All right, we have one more. Now I am certain that you can look at this one and balance that in your head probably almost instantaneously, but we are going to do this based on the half reactions just to get a little practice. So first thing we have to do is identify oxidation state. So iron's going to be 0 because it's by itself. Chlorine. So then that means iron is going to have to be plus 3 in order to get to 0. So then my 2 half reactions are going to be for iron and then for chlorine. Iron is going to be losing 3 electrons as it gets oxidized. Okay, then the chlorine one, Cl2 0, goes to 3 chloride ions. Okay, first thing, we need to make the number of chlorines equal on both sides of the equation. So we are going to put a 3 here, and we are going to put 6 there so that I've got 6 chlorines on either side. In order to figure out my charge, total charge would be 0 on the first side, total charge would be minus 6 on the second side, so I'm going to need 6 electrons. Because this side's using 6 electrons, I now need to multiply the iron reaction by 2. Then I put in the coefficients that I used, and then everything should be balanced. I should have 2 irons on each side and 6 chlorines on either side. In the chapter, you may see that there are some more complicated balancing redox reactions where you're balancing in acidic or basic solutions. That's not something that we have to cover, so we are going to skip over that. If you want to do it, you can read along in the book and ask me if you have any questions on it.